It still fascinates me.
The incredible beauty of the universe.
I call it a marathon and not a sprint.
We never wanted to be in second place.
Whatever I wanted to do, I felt that I could do it.
I think it's just very important to bring the power of science to understand behavior, to understand why people make the decisions they make.
Joanna Fowler brings the power of nuclear technology, originally designed to study the nature of matter, to the study of the brain. Fowler designs radio tracers, or chemical markers, which allow her to track brain activity via PET scan imaging.
Addiction is a disease of the brain. From these imaging studies, we've shown very significant differences between the addicted brain and the brain of people who are not using drugs. We're very interested in the reward system, so we look at tracers for dopamine, which is the neurotransmitter involved in reward.
Radio tracers have a short life. From creating the tracer to imaging the patient to analyzing the results, Fowler's work in the lab must be done at breakneck speed.
And the picture that's emerged now from all of these addictions is that it appears that the reward system is understimulated.
Not only is the reward system being affected, but so is the frontal cortex. This part of the brain deals with the consequences of behavior such as addiction.
And we're finding this pattern over and over, no matter whether you're looking at a cocaine abuser's brain or an alcoholic's brain, someone who abuses heroin or methamphetamine, or an obese person's brain.
Fowler has spent a career alongside mentors and colleagues designing radio tracers that have aided in the study of addictions, as well as the diagnosis and treatment of cancer. Her groundbreaking work in developing a radio tracer to track a brain enzyme revealed behavioral patterns associated with cigarette smoking.
So it's very reinforcing to work at something on the bench and then end up with some piece of knowledge about the brain that you never knew before. You know, I just lucked out getting into this area, and it's been so amazing being at Brookhaven National Laboratory because you can convene a room full of really smart people very rapidly to work on problems, and I think I'm the world's luckiest person.
Hello, everyone. I'm sorry I can't be here tonight, but I'm absolutely thrilled to receive this important award. It has personal significance for me because my career was started in the chemistry department at the University of South Florida, doing research in the early 60s. I want to thank the Florida Inventors Hall of Fame for this honor and for recognizing our work. I also thank my group at Brookhaven National Laboratory. We had a long history and tackled many difficult and important problems. People from all over the world were welcome. This openness helped ideas to flourish. One thought that I'd like to emphasize is that a strong and open scientific culture is essential for a healthy and prosperous future. This requires that we welcome the participation of the most creative scientists, no matter their ethnic background or where they come from. Thank you again, and my congratulations to the other people who are being recognized tonight. Good night.